Assalamualaikum and hi you all, welcome back to my video. In this video we're going to focus on the formula to estimate the differences between two population proportions. Okay, let me try to illustrate the situations to you. Let us consider the scenario of having two different populations. Okay, for example here I would like to define my population as male UMP students and female UMP students. And let's just say that I would like to determine the proportions of students who had been infected with COVID-19. And yeah, that will be my variable. Okay, my variable here is the number of students who had been infected by COVID-19 at least once. Okay, so but in this case I am interested to compare the differences between these two populations. Okay, I don't just want to know what is the pie for male and what is the pie for female, but I actually want to know the differences between these two populations. All right, so this is what I want to know. Okay, what is the differences between the population proportions of male UMP students that had been infected with COVID-19 and the population proportions of female UMP students who had been infected by COVID-19? Okay, so this is the big questions. So what I can do to understand the differences between these two pi is I can collect sample information from both populations. For example, maybe if I collect sample from the male students, I get that P is 0.2, and for the female students, maybe the P is 0.15. So by having these sample proportions, I can find the differences between the sample proportions of male and female, and I get 0.05. But these differences only represent the differences of the samples. It does not represent the differences of the population. It can be a good representative, but it is not the exact value of the differences between the population proportions. Okay, so in this video, I'm going to show you how we can use the differences between the sample proportions to estimate the differences between population proportions. This is the formula. Okay, there's only one formula, same as chapter 2.4. So I'm sure that you all are really glad about this, very happy about this. So the formula is just the differences between the two sample proportions, and then minus for lower boundary and plus for upper boundary. Okay, critical value z alpha over 2 multiply with this. Okay, that's it. That is the formula. And please note that for the differences between two population proportions, your confidence interval should be within the range of -1 to 1. Please make correction to your slide notes and your module. Okay, in the notes and module, it's written 0 here, but it's actually -1. Okay, when we find the differences, you can get negative value. Okay, when comparing differences between two value, it is possible to get negative, but for the case of proportions, the smallest possible value of the differences is -1. Okay, so -1 to 1. Now let's look at one example. Let's look at one example here. Example 2.10. Two different types of injection molding machines are used to form plastic parts. A plastic part is considered defective if it has excessive shrinkage or is discolored. Two random samples, okay? Two random samples, each of size 300, are selected. And 15 defective parts are found in the sample from machine 1, while 8 defective parts are found in the sample from machine 2. Construct a 98% confidence interval on the difference in the two population proportions of the defective parts. Give an interpretation for your answer. Now class, first and foremost, let us identify what is the variable, sample, and populations. I think it's pretty clear here. The sample is 300 parts from machine 1 and 300 parts from machine 2. So perhaps the population will be all parts from machine 1 and all parts from machine 2. But can you identify what is the variable from this study? What is the data that they collect from each sample. Yes, okay, the data is the number of defective plastic parts produced by machine 1 and the number of defective plastic parts produced by machine 2. Okay, well done. Next, let us identify, because this is about proportion, right? So for proportion, you need to define what is your success for this question. Okay, so you can find out that from looking at the instruction here. This is the instruction, okay? Difference of the defective parts. Yes. Okay, so for this question, we're going to define defective parts as our success. Okay, so now next, let us extract information. Sample size of 300. So X is the number of success. The number of success for machine 1 is 15 and the number of success for machine 2 is 8. Therefore, you can immediately calculate the sample proportion for each machines. Okay, and then the confidence level is 98%, which means your alpha is gonna be 0.02 divided by 2. It'll be 0.01, so that'll give you 2.3263 as your critical value. And yeah, you're ready to use the formula. Okay, substitute all the values accordingly, carefully. Okay, slow and steady, do this carefully, and you should be able to get negative 0.0131, 0.0597 as the confidence interval that will help you to estimate the differences between the population proportions of defective parts in machine 1 and machine 2. Okay, so now let's focus on the lower and the upper boundary here. Now this confidence interval tells us that the probability of finding the differences between pi 1 minus pi 2 within negative 1.31% and 5.97% is 0.98. Now let's try to understand the negative and positive value in this lower and upper boundary. Now remember class, when you're talking about the differences, okay, confidence interval for the differences, the negative and positive sign in your confidence interval has a certain interpretation. So try to recall chapter 2.3. Yes, try to recall chapter 2.3. So the interpretation here is similar to the one that I have explained to you in the class for chapter 2.3. So the negative value here does not mean that the differences is negative, does not mean that the proportion is negative 1.31. Okay, this actually means that this lower boundary tells us that between pi 1 and pi 2, pi 2 is greater than pi 1. So this is what the negative means. As for the upper boundary, you get a positive value. So this positive value indicates that pi 1 is greater than pi 2. So this means the lower boundary suggests that machine 2 produces more proportions of defective parts compared to machine 1, more by 1.31%. And for the upper boundary, it suggests that machine 1 produces more proportions of defective parts than machine 2, more by 5.97%. So that's why in the interpretation, you would need to write it like this. Okay, you need to interpret, we are 98% confident that the difference in the two true proportions for the defective plastic parts produced by using machine 1 and machine 2 is between 1.31% more by machine 2, correct, to 5.97% more by machine 1. Okay, compared to each other respectively. So this is how you interpret the differences between two population proportions in a way that you need to explain what does negative value means. Now please take note that the negative value should not be written in your interpretation because you had already interpreted by writing down more by machine 2. Is that clear? Okay, please take note on this. There's no unit. Okay, the negative has to be interpreted like this. And then, yeah, that's it. Okay, so this is the formula to estimate the differences between two population proportions. And yes, of course, there are also the formula for the one-sided lower bound and one-sided upper bound. And yeah, please also make correction for this slide. Okay, the differences of the population proportions should be within -1 to 1. It should range between -1 to 1. So for the one-sided lower bound, the biggest possible value of the differences is 1, and for one-sided upper bound, the lower boundary here should be -1. Okay, the smallest possible value of the differences is actually -1, not 0. So please make correction to your slide notes and also your module. Okay guys, so I think that is all for this video. You can proceed to try on the exercises. Okay, and please watch my next video on the confidence interval to estimate population variances and population standard deviation. Thank you for watching. I'll see you in my next one. Bye.